The future of space telerobotic communication and operations begins with the K-10 technology demonstration mission. How are astronauts in space trained to control the K-10 robot on the ground at NASA Ames? What are the future uses of telerobotics in space exploration? Grab your remote and find out next on NASA Edge.
Okay, guys, for this episode, I'm reprising my role as principal investigator for technology demonstration missions. That explains my seemingly lack of knowledge on the topic we're going to discuss today.
Did NASA approve this?
Pending. It's pending, but I did so well last time that I think it'll be no problem, and I will, just like Medley, just like my success story and case study, everything, I'll be set. So just go about your TDM business, and I'm going to be evaluating and asking key questions.
Well, Chris and I had a good time out at the Ames Research Center covering the K-10 TDM test. It was an early call time. We got there around 3 o'clock in the morning. Astronauts were awake, test team was awake, and we were wide awake.
Yeah,
Well, were you really wide awake at 4 in the morning?
That's debatable, but yeah. But it was actually the third test in a series of 3 tests where Karen Nyberg, who's an astronaut on station at the time, actually remotely operated the K-10 rover on the Roverscape.
Had she been the operator on the previous mission, or did they pass the baton amongst the astronauts?
Yeah, it had 3 different astronauts, and Karen was the third in the test, and then we had a chance to go out there, luckily, to cover her run.
Yes, and Chris talked to some of the engineers and software people that worked with the user interface that Karen was using on the ISS, and I was actually in the control room over there at the Ames with some researchers as they went through the test, and it was a pretty interesting morning.
But first, I had a chance to talk with Terry Fong, who's the project manager for the Human Exploration Telerobotics. He sort of kind of gave us the top-level approach of the whole surface telerobotics test conducted at Ames.
So Terry, tell us about the surface telerobotics test that we're going to be watching today.
Yeah, today we're having Karen Nyberg on the International Space Station remotely operate the K-10 robot here in the Roverscape at NASA Ames.
I understand you've been testing all summer. Have you been doing the same tests throughout the summer or different setups?
Well, the overall goal for surface telerobotics is to look at how astronauts in space, on a spacecraft like the space station, can operate robots on the surface of other planets. And we've been actually simulating a possible future lunar mission where you would have an astronaut in orbit above the moon control a robot to do work on the lunar far side. We've actually conducted 2 test sessions before today, and today Karen Nyberg is going to help us sort of round out the overall testing.
And what are sort of the objectives that we're looking at today?
Today we're trying to look at really the deployment of a simulated radio telescope. So Karen's going to be in charge of laying out a telescope with the K-10 rover, and then after that she's going to use the rover to inspect it and document the actual deployed location of the telescope. I think for us, really, the whole technology of telerobotics, or remotely operating a robot, is something that's very important for NASA in the future. On the space station today, we operate robot arms just on the other side of the bulkhead. It's not that far away. And for the future, we'd like to be able to extend the astronaut's reach all the way down from orbit to the surface.
I mean, what's it take to pull a test like this off?
This test really involves a collaboration between engineers, roboticists, scientists, flight controllers, mission operators, really a large team. There's work being done here at NASA Ames, at Jet Propulsion Laboratory, and also some colleagues at the University of Colorado Boulder. So it's a large team, but we're all working together to understand how we can remotely operate robots to really improve the way that astronauts can explore other places.
Tell us the difference between the 3 different tests that have been conducted here this summer.
Yeah, surface telerobotics as a whole is looking to simulate a future possible mission. This mission would involve deploying a radio telescope on the lunar far side. And so what we've done through our 3 test sessions to break that mission apart and test different phases throughout the 3 sessions. Okay. In the first session, Chris Cassidy used the robot to survey the terrain behind me. It was a simulated lunar environment. During the second session, Luca Parmitano deployed a telescope using a film-based telescope that was deployed off the back of the robot.
Okay.
And today, during the third session, Karen Nyberg is going to go out and inspect that deployed telescope.
What do you see the next steps for the surface for telerobotics testing?
Yeah, our testing this summer here has really been about collecting basic information to understand how to build this kind of system for the future. Once we finish the testing today, we're going to spend some time looking at all the data collected from the past 3 sessions to try to figure out how do we actually design and build future remotely operated robots.
So it's fair to say that at some point in the future, maybe in your lifetime, that instead of controlling, let's say, Curiosity from the planet and sending commands, we could actually have astronauts in orbit around Mars operating a robot.
Yeah, that's exactly right. I mean, it's our goal to enable astronauts to make use of these robots from any place in the solar system, whether they're controlled from Earth or from orbit, maybe even from the surface in a habitat, and just have robots working out in the field. It's really all the same thing. Remotely operated robots to improve the way that we do exploration.
All this technology that you're using here today, how does that benefit us in the public sector?
Well, the thing that really excites me about this technology is that it's really improving the way that we can use robots to do work remotely. We know already, in fact, that on Earth, you can use robots to explore the depths of the ocean from the surface. In space, we're trying to use robots like K-10 to allow astronauts to remotely explore the planets. But here on Earth, you can use the same sort of approach so that you or I could actually work at an office, say in Houston, while living in Hawaii. The whole idea of being able to live in one place and work remotely is what we're trying to really enable using robotics technology.
Is K-10 an actual concept that will be used on Mars down the road?
K-10 for us, it's a research robot here. It's got a lot of interesting technology that we hope to one day see in flight. The software that's on board, the software that's off board, descendants of those pieces of software may one day end up in an actual flight rover.
Now, is this really the prequel to R2-D2?
Well, I think that we're on a path to eventually have robots that are like the robots we see in the movies. And one of the things that's just so much fun about my job is trying to make science fiction into reality.
So you're you're sort of laying the foundation for the future.
Well, we hope so, and maybe not just the pavement, maybe we're actually moving along that road together.
I don't want to immediately bring up questions, but since I'm doing an investigation...
Is this really a pre-investigation, or is this...
It's a pre-investigation.
Okay.
It's at very early stages. Right. But my first question is, you guys claimed you were out at 4 a.m.
Correct.
Now, all I'm seeing is pure daylight in this interview. Now, you got to explain to me what's going on. I mean, were you really up early, or was... you're trying to pull the wool over my eyes, or what? I got to know, because I got to get the details correct.
We were sitting in the morning sun.
The morning sun.
Yes, it was just coming up over the horizon. We had to get there early to set up, and the team was in place, and it was done under the cover of darkness.
I mean, we actually started taking video when it was pitch dark outside.
Yeah, so.
But the cool thing you need to put in your investigation, or maybe ask if you're going to call Terry personally and ask him some questions, is the fact that one day astronauts will be operating, maybe not K-10, but other robots, whether they're orbiting Mars, they're orbiting an asteroid, the moon, other planetary bodies, and this is just kind of paving the groundwork for that.
Yeah, and it's really, I like the way you phrase that, because you're really getting to the point where you think differently. Usually we think of landers going to a surface and deploying out like this, but getting a rover perhaps, but now it's a rover, it's other robots, it's perhaps some other aerial craft that you may be controlling, a lot of telerobotics in the future. And so my question is then, how are these astronauts, particularly the ones that participated in this test, how are they even prepared to do this? How do you train to run a telerobotic situation while you're up on station?
He's the man.
Well, that brings us to our second interview with Maria Bourlat. She talked to me about this in the Multi-Mission Operations Center.
So we had no training on the ground before they went up to station. We're doing onboard training or just-in-time training.
Correspondence course? What?
Sort of, actually. Yeah, they read the manual for the GUI, for the crew GUI.
This is a video game they're playing.
In a way.
Did they really read the manual?
Some more than others.
You can tell?
Yeah, you can tell to some extent that we found that the GUI is very easy to use. We've gotten positive feedback.
Before you go any further, what's GUI?
Graphical user interface.
Okay.
So it's the interface, the screen that you work with, buttons and images.
Gotcha.
They're finding it very intuitive. So they're finding using the GUI is very easy, where the manual helps more is sort of in the operational issues of like, well, what do I do if I encounter this? It's not so much that they don't know how to make the robot do things, it's more, what do I do in this situation?
All right, if I were to sit down at a console and you put these controls in front of me and said, operate the robot, would I be able to do it by just looking at the screen? Are there any kind of on-screen directions?
Pretty close, yes. You have like a DVR?
Yes, actually I do.
Yeah, well, the controls for running plans on the robot, the task sequences, are basically like DVR controls. There's a play button, there's a pause button.
Idiot-proof?
Pretty close.
Okay, good
Yeah,
deal.
yeah.
All right.
The robot actually safes itself. So even if you tell it to run into a rock, it'll refuse to do so. So the robot says, there's an obstacle there. I can't go that way.
Speaking of running into a rock, while we were at the Roverscape, we found out about the 3D laser on top. Tell me a little bit about that.
On the ground, we use both the laser and stereo cameras, which is the way we as humans see 3D with stereo eyes. And that gives information about the shape of the terrain, where are the lumps and bumps and slopes. And so we depict that in the virtual 3D view that she has in the GUI. We show the shape, but we also color code it. So if it's nice and flat or a very small slope, it'll be green. If it's a little bit tricky, it might be yellow or orange. And if the rover will not drive over it or it's dangerous, it'll be red. And so that's how, when she's driving the robot around, she can tell whether it's safe to drive into a certain area or not.
Your technology demonstration is complete. Where to next?
That's actually a good question. For the most part, for the next few months, we're going to be analyzing our data. So we ask the crew a lot of questions. We want to look through all that and see what kind of feedback they've given us. We also want to understand some of the more sort of underlying technologies. So we've collected a lot of communication data, between the robot and the station. We've looked at, button presses in the GUI, rover telemetry as far as the rover's health and how it performed. So we're going to be analyzing a lot of data over the next couple of months.
So Maria, you've been up since 2, 3 o'clock this morning.
Yeah.
Your test is over. I think you deserve a vacation.
And I'm finally going to take one. One of the things about working with ISS scheduling is that you're not absolutely certain when your sessions are going to be scheduled. And so I didn't dare take vacation this summer because I didn't know when we'd end up having a session. So I'm definitely going to start taking vacation now.
So Blair, you're a gamer, right?
Absolutely, without question.
You know what? Maria made this sound so easy and the user interface so intuitive that even you could pick it up, because I know you'd never look at a manual when you open up a new game.
Yeah, but see, that argument's kind of a flawed argument. I mean, because I don't have to read a manual because I'm so good. It's not based on the simplicity of the game. It's because I'm a natural gamer and I'm talented in that realm.
There's a lot of swag coming from you right now.
Yeah, but you got to realize there's a big difference between controlling, let's say, a K-10 rover from ISS or a planetary system, as opposed to playing the Atari 2600 8 hours a day.
Wow.
You know
So,
what? You know what? I did see an old unit the last time I was over at your house.
I know.
But seriously, no, I think it's a good point. I mean, part of the reason it has to be simple, it's just like we talked about earlier. They don't have a lot of training or access. You don't spend hours preparing to drive this rover. They want something they can just pick and like plug and play.
Well, the difference between operating a rover on the surface of Mars and working in the ISS, the astronauts on the ISS are continually working on different projects. So they just got handed this one like the morning of. Karen got that the morning of. She opened it up and she made it happen. If you're going to train for a mission to Mars, you will definitely put some more time in on it.
That's a good point. Yeah, obviously NASA does a lot of complex things. Not everything they do is simplistic. So is the reason for simplicity now, does that have to do with the fact that you're developing a platform and the stakes are so high in terms of using ISS resources and putting these ground resources into play at a particular time?
I think it's just keeping it simple for the sake of keeping it simple. Nobody wants to decipher the Da Vinci Code while they're orbiting Mars. Yeah. Really, if you want to pick up and operate a rover that's going to be on the surface of Mars, make it work like a video game. Yeah. Keep it simple.
And if they can test the software and make it work and successful, I mean, you can apply it to a wide range of robotic vehicles, not just rovers.
Yeah, and so do you think for my investigation I should be able to download this software maybe and at least put it through its paces, on my Atari 2600, if you will?
Yeah, if it's in BASIC, sure.
Okay. Yeah.
We also had a chance, Franklin, to meet with the ops side. We met with some engineers and some researchers who were up with us at 4 o'clock in the morning.
So Susan, are you tired?
Yeah, very tired.
You're the engineering lead for the test.
Mm-hmm.
Kind of tell us what happened early this morning, starting at 4 a.m. when you started working and throughout the test itself.
So at 4 a.m. we start one rover at a time, and so we start up the controller, which is the software that runs the robot.
Right.
It's dark outside, so there's some things we can't test. We can't test the cameras and the navigation, but there are certain parts that we can test, like to make sure that it can drive. So we get the first rover all set up, taken outside, then we move to the second robot, and then we run a couple simple tests just to make sure we're connected to the rover,
Right.
we're getting the data.
Right.
Then it's listening to the loops, the space to ground loop, which is when the astronaut talks to mission control, and try to anticipate or see any problems before maybe they even notice it, so we can have an answer or a fix for them as soon as possible.
How do you even get the signal from the International Space Station down to the K-10 rover?
It goes through a lot of different places. So from the ISS, it went through JSC, which is the mission control. And from there, we had a router that actually routed the message from the ISS to here at Ames to the K-10. The message layer that it was using was something that we developed here called Rapid, and allowed us to write our software and communicate and let Karen control the robot here at Ames.
Now, with all that, what kind of delays were we talking about in terms of Karen operating the rover to actually seeing the rover move?
Surprisingly, we were expecting quite a bit of delay, but it ranged between a second to maybe even less than that. So it wasn't that long. Although we did have a video feed, and we could see the delay where we'll see the messages here, and then it'll appear on her workstation.
Basically what you're saying is it's faster to send a signal down from the ISS to the K-10 than it is for me to get on the internet and go to some of these websites.
Yes, definitely.
Right. Now during the actual tests, there would be times where it would go in maybe 4 or 5 feet, and then it would stop. And then you have a 1 to 2 minute period where it was stationary, and then it would go again. What's going on during that lag time between runs?
So usually it's taking a camera image. So we have a downward facing camera called the inspection camera. And when we're deploying the film, for example, we like to take pictures, every couple meter or two, so that the astronauts could tell us, oh, there's a tear in the film, or this doesn't look right, it didn't deploy properly. Other times it's taking a panorama, so it's trying to get a bigger picture view of, did it lay out the film correctly? Are there interesting features in the view?
But besides the pictures, Karen can see that in real time with the cameras.
The hazard cameras, or the navigation cameras, which help the robot see obstacles.
They're the 2 cameras at the very top, like the eyes.
Yeah, the eyes.
Right.
And so she sees that feed in real time. But there's also other cameras that are higher resolution and in color, and those are only taken when we ask.
And is she taking those stills herself? Or?
Yes. So in the plans, there's certain points called waypoints.
Right.
And at each waypoint, you might have a command to take an inspection image or a panorama image. And if all things go as planned, it'll go to those stations and take those images. But sometimes, it'll take an image and you'll be like, this isn't the image that I wanted. It's not pointing the direction. Right. Then it's Karen, the astronaut's responsibility to, maybe rotate the robot a little bit to take the image that the ground requested.
Now, what do you see as the next steps for this?
I'm hoping for, in future missions that we can not only control K-10, but other robots that were developed by NASA or anyone else. Any robot that uses this framework will be able to be controlled in a unified software. Hopefully we can get some future missions so that the astronaut can not only control K-10, but also athlete from JPL, maybe the MMSEV from GSC, and some of the other robots from other different centers. And not only can it be used in a variety of ways for space exploration, but maybe in the medical field, remote controlling of a robot, as a doctor is in United States and he has patients in other places, and maybe even deep sea diving, and so yeah, there's a lot of applications that we can see for this in the future.
Take the turn.
We thought for a second that Karen was doing some 4-wheeling.
Yeah, so K-10 can go over small rocks about maybe half the size of the wheel. It can actually go over bigger, but we don't let it.
So how did it go today, from your perspective?
I think it went really well. Yeah, we always expect there to be small problems here and there, but we developed a bunch of contingencies, like if this happens, then this is what we're going to do. So we've been preparing for a really long time, and I think it paid off today.
All the engineers and technicians that worked that mission, they were pretty young.
Yeah, they're of the gamer generation, and they know how and what it feels like to work with software that is easy to use. And I think that's one of the things that they were trying to do with the astronauts in this TDM.
I think you need to keep in mind with that report is look at the age of these engineers. I mean, they're not just, they're not 50, 60-year-old folks. I mean, these are young people, just fresh out of college or 5 or 6 years out of college.
Chris does not like older. Yeah.
Okay.
No, it's an interesting point. I think part of that is just the emergence of the technology and the life span that it has, because it seems like even though this demonstration is going to help NASA in the short run, you see tons of long-range applications for it.
Right.
I mean, I'm just wondering one day, am I going to be sitting there gaming, playing my particular console and decide, well, I want to go take a flight around Mars, and I'll control a drone or something, or control some kind of rover and do my own work as just an average person.
Or better yet, you're a student in a 5th grade class, and today's topic is robotics, and every kid is operating their own rover on another planet.
From their iPad.
From their iPad.
iPad? Are you kidding me? Those will be passé by the time.
You're watching NASA Edge.
An inside and outside look.
At All Things NASA, if they pass my investigation, by the way. I didn't want you to lose the impact of the significant moment for me, so bear that in mind.
Quit your jibber jabber.
What was that? What was that?
First name, Mr. Middle name, period. Last
Hold up,
name.
what was that?
It's my Mr. Tina pocket.